Hello everyone, the current study is experimental and computational study on the dynamic analysis of crack simply supported structures under a moving mass. The present study is focused out to carry out a undamaged beam, single crack beam, double crack beam and triple crack beam under moving mass used both by numerical analysis, finite element analysis and experimental verifications. This is the theoretical model of the moving mass structures. The main objective of this study is to find out the influence of the location of the cracks, number of cracks, crack depth, magnitude and speed of the mass on the vertical deflection of the simply supported structures. If you study the governing equation of this motion, so here you are finding out del square by del t square is nothing, the vertical acceleration, v square del square by del x square is nothing, the centrifugal acceleration, 2v del square by del x del t is nothing, the Coriolis accelerations, delta is nothing, the Dirac delta functions which has been used to find out the position of the objects. The governing equation has been solved to find out the deflection using Duhamel integral approach. Coming to the experimental part, here you can say the controllers are used, PLC controller which has been used to fix the desired speed. Sensors has been used to find out the or to read the exact deflection at different locations. Coming to the FE analysis, you can see the crack has been modeled using ANSYS 2020. So here this is the experimental zone of the crack and this is the moving mass structure dynamics. Now coming to the comparison graph, here you have done the comparison graph between numerical, FEA and experiments. You can find at some extent there is sudden rise in dynamic deflection or amplitudes. So that is nothing, it is happening due to the which one? The presence of the cracks. Coming to the comparison results between numerical and experimentals, here you can find out total percentage of deviation between numerical and experiment is around 3.85% error, while that of FEA and experiments we are finding out 2.51. So coming to the conclusion parts, whatever we have discussed here, that is nothing. The beam deflection will be increasing if we are increasing the moving mass and the crack depth. Again, if the crack location gets far from the left end, which is the point where the motion begins, the vertical deflection of the beam starts decreasing. The beam behaves more rigid in undamaged case, and the cracks in the beam cause an increase in local flexibility, which is detrimental of the structures. The number, the depth and the position of cracks, the mass and the velocity of the contingent loads influence the dynamic response of the damaged structures. So the deflection of the crack structures are mostly affected by mass magnitude of the moving load compared to the crack features.